In the process of light propagation, when encountering a medium, part of the incident light flux is reflected, part is absorbed, and another part passes through the medium and enters the space on the other side. The luminous reflectance is equal to the ratio of the reflected luminous flux to the incident luminous flux. The optical absorption ratio is equal to the ratio of the absorbed light flux to the incident light flux. The luminous transmittance is equal to the ratio of the transmitted light flux to the incident light flux. According to the law of conservation of energy, the sum of these three paths is equal to the incident light flux. Then rho plus alpha plus tau equals 1. Reflective and transmissive materials are divided into two categories. One is regular, and the solid angle of the light does not change after reflection and transmission, such as mirrors and transparent glass. The other is diffuse, which spreads the incident light into a larger solid angle according to different degrees, such as pitted walls. The regular reflection of light hitting an opaque material with a smooth surface is also known as specular reflection. It is a reflection that follows the laws of geometric optics under the condition of no diffusion. The characteristics are 1. The incident angle of the light is equal to the reflection angle. 2. The normal of the incident light, the reflected light, and the reflecting surface are in the same plane. The light source can be clearly seen in the reflection direction, such as point B in the red image. After moving the position of the eye or the smooth surface, the light source cannot be seen by avoiding the reflection direction, such as point A in the red picture. Taking advantage of this feature, placing regular reflective surface in the red space can reflect light where it is needed, or keep light source out of sight. The light strikes the transparent material to produce regular transmission. Regular transmission is transmission that follows the laws of geometric optics under the condition of no diffusion. If the two surfaces of the material are parallel to each other, the light passing through the material remains parallel to the incident direction. The brightness and luminous intensity of the light source after the regular reflection or transmission of the material is larger than the original brightness and luminous intensity of the light source due to the absorption and reflection of the material, which is equal to the original brightness and luminous intensity multiplied by the light reflectance or light transmittance. Translucent material diffuse and transmits incident light. An opaque material with rough surface diffuses and reflects incident light, so that light is dissipated in a larger solid angle range. Such materials are classified into two categories according to their diffusive properties: diffusive materials, mixed reflective and mixed transmissive materials. Diffusive materials, also known as uniform diffusive materials, reflect or transmit incident light evenly around with the same brightness in all directions, and the light source cannot be seen. The maximum luminous intensity of the diffusion material is in the normal direction of the surface. The luminous intensity in other directions is equal to the luminous intensity in the normal direction multiplied by cosine I, where I is the angle between the surface normal and other directions. This relationship is called Lambert's cosine law. A complete diffuser is called a Lambertson, a Lambertson illuminator, cosine illuminant. From a distance, the cosine luminous sphere looks like a luminous disk, and the sun is the cosine luminous body. There is no regular reflection in diffuse reflection, also known as isotropic reflection. Building materials such as whitewashed walls and brick walls can be regarded as such materials. There is no regular transmission in diffuse transmission, such as opal glass, translucent plastic, etc. The light source cannot be seen through it. Only the natural color and brightness of the material can be seen, and it is often used to reduce the brightness of the light source and reduce the degree of glare. Hybrid materials have both regular reflection and diffusion, diffuse reflection and transmission. It has the maximum brightness in the regular reflection or transmission direction. The light source can be seen, but not clear enough, and has a certain brightness in other directions. Mixed reflections have both regular and diffuse reflections, such as smooth pattern and paint. Hybrid transmission has both regular and diffuse transmission, such as frosted glass. Next, let's do two exercises. It is known that the wall of a certain room is decorated with latex paint. The light reflectance is equal to 0.7, and the average illuminance of the wall is 50 lux. Find the average brightness of the wall. Since the latex paint wall is a diffuse reflection material, the brightness is obtained from the known illuminance. Therefore, the brightness is equal to 50 times 0.7 and then divided by 3.14, which is equal to 11.15 candela square meter. Given a milky white glass spherical lamp set with a diameter of 250 mm, the light transmittance is equal to 0.6, and an incandescent lamp with a luminous flux of 1260 lumen is installed inside. Find the brightness of the outer surface of the lamp set. Since the lamp set is a diffuse transmission material, the illuminance needs to be used to obtain the brightness. Therefore, the illuminance of the inner surface of the lamp set is obtained first, and then the illuminance is used to obtain the brightness. First, using the definition of illuminance, E is equal to 6420 lux, where R is equal to half of 0.25. Then, using the brightness calculation formula of the diffuse transmission material, L is equal to 1227 nit. Think about it. Can diffuse materials be showed by the relationship between illuminance and brightness? Is the illuminance in the relationship between illuminance and brightness the same as the illuminance in the calculation formula for the brightness of a diffusion material? What occasions are suitable for using regular materials and diffuse materials? What types of light environments can diffuse materials create?